Angle relationships. Now note, some angles have more than one relationship. Check it. Let's begin with complementary. Two angles are said to be complementary if they add up to 90 degrees. So for example, we say that angle A and angle B are complementary because they add up to 90 degrees. Now, saying that conceptually is nice, but what we also run across is that now we can use mathematics. Now we can go ahead and set up an equation, right? So for example, 30 degrees plus 60 degrees is 90 degrees. Angles F and G are supplementary because they add up to 180 degrees. Note that again we can go ahead and set up an equation for this. Instead of making it equal to 90 degrees, we're making it equal to 180 because this is supplementary. We say two angles are adjacent if they share a common vertex and a side. So for example, we say that angle 1 and angle 2 are adjacent because angle 1 and angle 2, they share the same side and they have the same vertex right here at this point. We also know that angle 1 and angle 2 are complementary. How do we know they're complementary? Because they add up to 90 degrees. How do we know there's 90 degrees? This symbol right here, when you see a square, this square means 90 degrees. It means right angle. It means perpendicular. So if it forms a right angle, by definition, a right angle is 90 degrees. If these two angles combine to form 90 degrees, then these two angles must be complementary. You will note at this point that vocabulary is a heavy component of this mathematical course. And it's crucial that you understand all of these words. Otherwise, it'll pile up very quickly and you'll fall very behind very quickly. We will note, for example, that angle A and angle B are not adjacent. And that's because they're not touching the same vertex, and they're not sharing or touching the same side. So in order to be adjacent, it must be sharing the same vertex and sharing the same side. That is, two angles are doing that. We say that two angles are vertical angles when they are across from each other and they share a vertex, and they are congruent. So if I have two vertical angles, they're congruent. So in this example, we have angle 1 and angle 3 are vertical angles. Also, angle 2 and angle 4 are vertical angles. You'll note that it's the angles across from each other. These are formed by two lines. All four share the same vertex, but we're looking at the pairs that are across from each other. Now, based on our theorem, if we have two angles and they're vertical angles, they are congruent. In other words, we can say the following. Recall that congruent means same shape, same size, same value. So for practical purposes, we can say that angle 1 is equal to angle 3, if that helps. So for example, if angle 1 is 30 degrees, then by our theorem, angle 3 must also be 30 degrees because they are congruent. Congruent is like a super equal. You gotta know what congruent means. It's gonna happen the rest of your life in this class. Another example, so let's say we know that angle 2 is equal to 150 degrees. According to vertical angles, that means that the one across from it, angle 4, would also be 150 degrees. Now, you can use a bit of common sense here because you note, hopefully, that this is an acute angle. Angle 3 is acute. So expect an angle less than 90. And then angle 2 and 4, for example, are obtuse, meaning they're going to be greater than 90. So expect a number greater than 90 in this case. So it's okay to look at these and say, hey, I expect this to look like something like as follows. And then go ahead and allow that to help confirm what you're getting mathematically. A linear pair, and please note that in each case we say 2, right? If two angles are complementary, if two angles are supplementary, if two angles are vertical angles, if two angles are linear pair. note that we're dealing with twos, with pairs of angles, not with 3 angles or 4 angles. The angle addition postulate allows us to relate multiple angles with each other at the same time, but these definitions and theorems that we're giving you right now are only for pairs of angles. So a linear pair, hint, forms a line. A linear pair are two angles that add up to 180. It's supplementary. So we could also write the following statement. Angle 1 plus angle 2 is 180. Now, this might look familiar because a few minutes ago we talked about supplementary. This is a special type of supplementary. It's called a linear pair. And a linear pair is a pair of adjacent supplementary angles. So if you look back at the angles we drew for supplementary, they were not touching. They were not sharing a side. They were not sharing a vertex. Those were not a linear pair. They were supplementary, but they were not a linear pair. These two angles are supplementary, and they also form a line. There's a line. And we know that a line is a straight angle, and a straight angle is 180 degrees, and that's we're saying that angle 1 plus angle 2 is equal to 180 degrees. This is convenient, right? So if this is a linear pair and angle 2 is 60 degrees, then I would have to go ahead and see what angle 1 is, but I know they both add up to 180 degrees. So that means angle 1 must be 120 degrees.
Oh yeah!
If we look at this picture up here, we have vertical angles, right? We have 1 and 3 are vertical, 2 and 4 are vertical. However, we also have multiple linear pairs. So for example, angles 1 and angle 2 form a linear pair. They form this line right here. We have angles 2 and 3 that form this linear pair. They form this line. We have angles 3 and 4 that form this line. And we have 4 and 1 that form this line. So we know that we have 4 pairs of linear pairs. Each of these pairs of linear pairs, if I add them up, is equal to 180. So for example, if we note angle 1 plus angle 4 in this example, that's 30 plus 150. It's 180 degrees. It forms a straight angle. It forms a line. It's just two supplementary adjacent angles that form a linear pair. Get used to your vocabulary, please.
Perfect.
Let's look at a few pictures and let's do a little bit of math and a little bit of thinking. So, looking at this first one right here with angle 1 and angle 2, this looks familiar. Okay, we note the little square right here. That square implies that this forms a 90-degree angle.
Oh yeah!
And what we have here is we have angle 1 and angle 2 are complementary. We also know that they share a side and they share a vertex. This also makes angle 1 and angle 2 adjacent. Now, as far as a mathematical equation is concerned, because these two angles are complementary, they add up to 90 degrees. That would allow us to find out that missing angle, angle 2. If we go ahead and subtract angle 1 from the total 90 degrees, we would get 28 degrees for angle 2. And you can check that, right? 28 degrees plus 60 degrees is 90 degrees.
I just cannot believe this!
For these next angles, we don't quite see a line being formed anywhere. We have a 37 degree and a 127 degree, which does not add up to 180. It adds up to a different number. So we can say that this angle plus this angle is 180. And if we can't say that, they're not supplementary. However, you'll note that 127 plus 53 is 180. So we could say the following. We could say that angle CAD and angle SRT are supplementary, and therefore we could write the following equation because they're equal to 180 if you add them up. We also know that if we add 53 to 37, we get 90 degrees. Therefore, angle CAB and angle RST are complementary. That means they add up to 90 degrees. So what we see before us, we see two supplementary angles. We see two complementary angles. We don't have vertical angles. We don't have a linear pair. we do have two adjacent angles. We have these two angles that are sharing this side, and they're sharing a vertex. So we can say that angle CAB and angle CAD are adjacent. You don't have to be supplementary or complementary to be adjacent. Adjacent just means you're sharing the same side and the same vertex. Adjacent means my neighbor who shares a fence with me and we share the same sewage system. Okay? So adjacent is right next to me, touching, sharing a fence. The person across the street from me is not adjacent. Okay?
I think I need a hug.
For our next one, we have a linear pair because it forms a line. So angle 4 and angle 3, they form a linear pair. If it's a linear pair, then it's supplementary. And that means that it adds up to 180 degrees.
Perfect.
And if they add up to 180 degrees,
Perfect.
that means angle 3 has a measurement of 130 degrees. Angle 4 is 47 degrees. If you add those two, you get 180. You'll also know that because it's a linear pair, angle 4 and angle 3 are adjacent. So what could we say for this picture right here? We can say the following. Angle 4 and angle 3 are adjacent. Angle 4 and angle 3 are supplementary. And angle 4 and angle 3, because they meet both conditions, form a linear pair. And if they form a linear pair, then the angles add up to 180 degrees. That kind of processing and thinking and rationale is pivotal to your success in the rest of the year in this class. So today's lecture is actually pretty pivotal for the rest of the year because we're giving you some good habits that you need to form. Angle 5 and angle 6. Well, once again, we're looking at a pair of adjacent angles, and they form a line that makes them linear, a linear pair. And if they're adjacent and they form a linear pair, that means they're also supplementary. So angle 5 and angle 6 are two adjacent angles that form a linear pair. How do I know they form a linear pair? Well, good golly, this is a line. Right? That was lesson 1.1. We talked about lines. And if it forms a line and they're adjacent angles, then it's going to be supplementary. Here's a nice beefy one. So let's kind of talk you through this. I'm not going to write as much probably. I want to just talk you more through it. So we note that there's two lines that are intersecting at this point right here. We see four angles being formed. All four angles have the same vertex. Let's observe the ones across from each other. So we know angle 2 and angle 4 form a vertical angle. I should say a pair of vertical angles. And therefore, angle 1 and angle 3, you should write these down. I'm not going to write them down, but you should write them down. Angle 1 and angle 3 are also vertical angles. Okay? So there's two pairs of vertical angles for this one. Furthermore, we have some linear pairs. So for example, 4 and 1, they form a line. So angles 4 and angle 1 form a linear pair. And again, I'm not going to write these all down, but you should. I want to kind of talk you through them. We have also angle 1 and angle 2 form a linear pair because they're adjacent supplementary angles that form a line. Angle 2 and angle 3 are also a linear pair because they're adjacent angles that form a line. They're supplementary. And finally, angle 3 and angle 4 are also a linear pair. So what you should have written down, you should have two sets of vertical angles, 2 and 4, 1 and 3, and you should have 4 sets of linear pairs.
Oh, yeah. Perfect.
Let's do some quick math here. So complementary means they add up to 90 degrees. So if I have a 3-degree angle, what's the complement of that? 87 degrees. What about if I'm given a 17.3 degree angle? Well, the complement for that would be 72.7 degrees. The complement of 45 degrees would be 45 degrees. And that, by the way, that would mean that the two complements are actually congruent, right? They're the same measurement, the same value. They're equal to each other. It's a rare situation, but it's true in this case. And finally, if I'm given an 88-degree angle, the complement of that would be 2 degrees. What about supplementary angles? Well, those add up to 180 degrees, right? It's two angles, not three, two angles that add up to 180 degrees. So if you give me a 13-degree angle, then a supplement of that would be 167 degrees. If I were given a 90-degree angle, the supplement of that would be 90 degrees. And again, here's a special case, right? Like usually these are not equal to each other. They're not congruent. So this is the one case where two angles are supplementary and they happen to be congruent as well. It's pretty rare. This is the only case. If I'm given a 121-degree angle, then I have a 59-degree angle would be its supplement. And then if I'm given a 178.5-degree angle, the supplement would be 1.5 degrees. For your summary, if two angles are supplementary, must they be a linear pair? Must. Give me examples or counterexamples.
Perfect.